Hi everyone, thanks for dropping by my YouTube channel today. On my workbench this evening I have Charles's QuadraFire brand pellet stove controller. It's a model number 230-1844. Charles and I have been discussing this controller quite a bit over phone and through texts. It sounds like he had a pretty drastic problem with the stove and it blew up some of the circuit board inside the controller box. So after trying a number of remote fixes, it was decided that Charles should send me this controller. I'd have a look at it and see what could be done about it, what could be wrong with it. So I received this controller last week. I opened it up and sure enough I found a number of issues with the circuit board. I've repaired all of those issues, did some initial testing, and I find the controller to appear to be fully functional now. So I'm ready to return it to Charles, but before I do I wanted to do a video document of it. So this final test will be that exactly. As you can see, the controller is currently on my workbench. It's hooked up to my tester. My tester is made up of a number of items. I have a temperature simulator here, which is currently set to 45 degrees Fahrenheit. Behind this faceplate is mounted an actual auger motor. The shaft from the auger motor comes out the front. There's a decal on it for X marks the spot. So when the controller is going to ask for the auger to drive, we'll see that decal spin. We'll also hear the auger motor run. I also have a thermostat here, just like you have on the wall of your house, and a green light at the top of the controller, which is a call for heat lamp. So when I do a call for heat using the thermostat, we should see that lamp come on. At the back I have 4 light bulbs. On the very far left is the igniter simulator light bulb. That will simulate when the igniter comes on, called by the controller. I have a blue decal light in the second position there. That light simulates the combustion or the firebox fan. It is on currently because I have the system on. In yellow we have an auger simulator which is not running right now. You see the light is off. And at the far end I have a red indicated light which simulates the room fan. Now with this test setup I can simulate the room fan go on high or go on low. As you can see, the intensity of the light changes. That will cause the fan to run faster or slower. In the QuadraFire with this model of controller, as you can see it's a black box with a gray bottom, it will send out a signal to drive the room fan, and a switch inside the furnace will determine if that fan should run or not. So depending on the temperature of the stove, that fan will or will not come on based on that switch and based on the voltage that this controller sends out. So as you can see, I'm at approximately 45 degrees Fahrenheit. I don't have any lights on the side of my controllers. They're both off. So let me do a call for heat and I'll turn on the thermostat. And when we do that, we see a couple lights have come on. We see the auger motor spin up and we see the igniter has come on. We also see the green light here doing a call for heat. So everything there is functional. I'm going to increase the temperature from the 44 that I'm at and slowly increase it so that we can see the green light on the side of the controller come on. I hope we can see that in the camera. But as I increase the temperature, slowly, there it is. So at about 165, 170 degrees Fahrenheit, we see the green light come on and off. And we don't hear any ticking because this is a solid state relay inside here. So everything's fine so far with the green light on at about 180 degrees Fahrenheit. If I increase the temperature to about 550 degrees Fahrenheit, we'll see the red light come on. So let's do that. And when the red light comes on, we see a couple things happen. There it is. The igniter has shut off and the auger goes into cycling mode. Notice short cycles. So everything there is functional. Short cycles of the auger to feed pellets into the fire, maintain the fire. The igniter is no longer needed because we're at above 550 degrees Fahrenheit. The room fan could be on based on the body temperature of the stove. The combustion fan is running to keep the fire going. And everything is self-sustaining at this point. Red light, green light, self-sustaining. That's the way it should work. If I decrease it, we're no longer self-sustaining. The igniter comes back on. And the auger is not driving right now. We're not feeding more pellets into the stove. The fire catches again with whatever's in the fire pit. The red light comes on, the igniter goes off, and the igniter or the auger starts cycling. There it is. So that's the operation of this controller. Charles, I do want to thank you very much for sending me your controller. I appreciate it very much. As we spoke over the phone, I believe you have some issues in your stove that needs to be rectified. So I'm going to send this back to you now. Please try to take care of what's in your stove, and let's keep in touch so that we can help each other out fixing this once and for all. For all you viewers out there, if you have a pellet stove controller of your own, whether it's a QuadraFire, Breckwell, or USSC, and you have some maintenance issues for it, please be sure to let me know. I'd be more than happy to speak to you about it. In the meantime, I hope you'll take a few seconds to give this video a thumbs up and subscribe to my channel. I would appreciate that very much. Thanks everyone. Bye-bye.